Hey everyone, welcome back to the Foundry by Forge College. I am super excited you're here today because we get to put on our detective hats. As gumshoe engineers, we're going to track down some mischievous deployment bugs that are just wreaking havoc in our code. Look, we've all been there, right? Staring at a terminal screen wondering why our perfectly written smart contract is suddenly throwing an absolute tantrum. Well, today, let's explore how to transform that frustration into a calculated, scientific process. Okay, here's our exact game plan for today. We'll go from detection to action, set up our lab, walk through the 7-step workflow, correlate our evidence, verify the fix, and wrap it all up with the debug report.
Section 1. From detection to action, moving beyond the symptoms.
So in our last explainer, we talked about how to read the symptoms of a sick deployment and spot error patterns. But observation alone doesn't fix a broken program. We have to shift our focus from just watching those symptoms to actually taking hands-on action. It's the classic developer's dilemma. We know it's broken, now how do we fix it? It's super easy to look at a blaring red error log and panic, but we need to treat this broken code like a pristine crime scene waiting to be investigated. We can't just start guessing and changing lines of code at random. We need a method to the madness to collect the clues, secure the perimeter, and methodically piece together exactly what went wrong.
And that brings us to our ultimate goal, the debug report. Think of this as your official detective's case file. It is definitely not just a quick Slack message saying, "Hey, I fixed it." No way. It's a step-by-step, evidence-backed record. It includes exactly how you reproduce the error, the correlated logs and metric snapshots you grabbed, your logical reasoning for the root cause, the exact remediation steps you took, and the definitive proof that your fix actually worked. It's the ultimate proof of how we solve the mystery.
All right, Section 2. Setting up the lab, building your controlled environment.
Look, before we even think about poking this bug with a stick, we need a safe environment. If you try to debug a chaotic issue live on mainnet, you are essentially trying to defuse a bomb in a crowded room. It's a terrible idea. We need an isolated test validator to lock the bug away where it can't accidentally blow up production. Here are the exact tools you'll need to set up your forensic lab. You'll need the Solana CLI to spin up a local test validator, your Anchor CLI or build tooling to compile and deploy, a metrics exporter like Prometheus to capture latency and throughput, and local log collection to grab those structured JSON logs. And finally, absolutely crucial, a reproducible failure script. Just a little piece of code designed specifically to trigger the crash over and over again. Trust me, a clean lab environment is literally the difference between an hour of debugging and a week of absolute misery.
Moving on to Section 3, the 7-step workflow, the blueprint for catching bugs.
Professional troubleshooting isn't random guessing. It's not just changing a variable, hitting deploy, and crossing your fingers. It's a strict, repeatable 7-step checklist that we follow every single time an incident happens. Let's walk through the capture and triage phases. Step 1, establish your baseline. Take a snapshot of what normal looks like before you touch anything. Step 2, reproduce the incident. We run that failure script to trigger the issue on purpose. Step 3 is triaging the logs, filtering through all the noise to find the specific error or panic traces. And Step 4 is where we set our traps. We correlate the performance metrics to those specific log events. We're essentially catching the bug red-handed right in the act of tanking our performance.
Then we hit the resolution phase. Step 5 is narrowing down our root cause hypotheses based on the evidence we gathered. Step 6 is testing a minimal fix or mitigation. And Step 7 is validating that recovery against our original baselines. Let's say your hypothesis for Step 5 is an unbounded loop. It's kind of like a dog chasing its tail, right? It's consuming massive amounts of energy, tying up all your resources, and getting absolutely nowhere until it just passes out and crashes your program. Once we spot that, we apply a targeted fix and move straight to validation.
Section 4, correlating the evidence, connecting the dots.
Now, this is arguably the most critical part of the entire investigation. Having a pile of error logs over here and a separate pile of latency charts over there doesn't actually solve the case. We have to line up our clues to find the smoking gun that definitively proves why the failure happened. And to find that smoking gun, you have to look at timestamps and transaction signatures. They are the forensic DNA at the crime scene. If you have an error log that happens at the exact same millisecond that your P99 RPC latency suddenly spikes to the moon, yeah, that is no coincidence. You use the transaction signature from the error log to query your metrics, linking that specific broken code directly to the network congestion it caused.
What's really cool here is how we map raw evidence to a concrete interpretation using specific tools. See an error log with a panic?
You use a JQ filter to isolate it, and boom, you instantly know you have a runtime error. Notice an RPC latency spike on a Prometheus query? That strongly suggests congestion or blocking. Spiking transaction retries on your validator metrics? That might point to ordering conflicts. We are taking raw data and translating it into highly actionable insights.
Which brings us to Section 5, verifying your fix, proving the case.
Okay, so you've written a fix. You've deployed it to your local test lab. Awesome. But we can't just assume it works. We have to prove, beyond a shadow of a doubt, that our targeted fix actually cured the patient and didn't just hide the symptoms. It is absolutely not enough for the error log to just vanish. Sometimes a bug fix just moves the error to a totally different part of the stack. To truly verify, your performance metrics, specifically your P50, P95, and P99 latencies, along with your error rates, must return to those initial baseline snapshots we took back in Step 1. We're directly comparing the before and after pictures of our system's health.
And here's what that visual proof looks like. Bar 1 on the left is our baseline, nice, low, healthy latency. Bar 2 is the incident, just a massive spike where our P99 latency went totally off the charts. But look at bar 3. Our verification phase during load testing is completely flattened back down to match the baseline. This is the definitive visual proof that our code change resolved the performance bottleneck entirely.
Finally, Section 6, the debug report, filing the final case report. Any good detective will tell you that the job isn't done until the paperwork is filed. This report is what you hand to your team lead or attach to the post-mortem to ensure that this specific bug never wastes your team's time again. Here is your mandatory checklist for a successful report. You must include the exact reproduction steps. You need the baseline snapshot, the incident evidence, and your correlation mapping. You've got to document your root cause validation, the exact remediation steps you took, and finally, the verification evidence. Literally, every single terminal command, every piece of code you changed, and every output log must be meticulously documented right here.
I want to leave you with one final provocative thought today. Look at your debug report and ask yourself, can another engineer follow my exact steps and reach the exact same conclusion? If the answer is no, well, your investigation isn't finished. Reproducibility is the absolute gold standard of engineering. I highly encourage you to take these techniques and apply them to your own workflows. And hey, if you found this explainer helpful, I definitely recommend you visit forge.college to explore more incredibly structured content on Web3 operations and deployments. Keep learning, keep experimenting, and I'll catch you in the next explainer.